Okay, this is the Pre Calc 1.9 lesson over inverses. Take out your note sheet, we'll follow along with this and do the notes that you need. So you've dealt with inverses before. The first thing that you need to think about is what the notation for an inverse is. And there's actually a button on your calculator called x to the negative 1. That's the actual inverse button on your calculator. You could use that button to find the inverse of a number. Now, you really can't do it for, there are ways of doing it for some graphing things and some various other ideas, but for right now, for an inverse for us, the notation is this little negative 1. So this f of x is the function f of x, and then if you ever see a little superscripted negative 1, what they're trying to do is telling you to, hey, find the inverse of that function. And you've done inverses before. If you multiply inverses together, you get 1. And I put it like in air quotes because it won't always be 1. If you add inverses together, if you have inverses on a graph, there's this idea of what does 1 look like in that scenario. An example of this, 1/8 and 1/8 are called inverses, and you get 1. Well, what is the 1 idea on a graph? Well, I mean, you could think about this a lot of ways. You could think about it as y equals 1 or x equals 1. But what we think about the 1 idea on a graph is this line that goes perfectly through this quadrant, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So this is the idea right here of 1 on a graph. And it's the line y equals x. Y equals x is our inverse line. Inverse line. And what you should be able to do on a graph with the inverse line is there's an ink thing I call the ink blot test. It's called the Rorschach test. If you're in psychology, that deal where you have a little blot of ink and then you push it together and you open it up and you say, oh, what do you see? And if you see like death and war and whatever, then they send you to the other people. And then if you say like, oh, sunshine and flowers, then you're okay and you're not whatever, okay? The ink blot test. Well, ink blot test on this is, imagine if this were a line that I was going to fold. Oh, you probably did this in like grade school where you did the little blobs of paint and then you made your little butterfly here out of your blobs of paint and you made them symmetrical. Oh, and it's, oh, everything. And then, boom. And then this is supposed to be the same. I should have even, maybe I have a dot over here and a dot over here and a cross over here and a cross over here. And that's a really bad picture. But the idea is that I fold across the line. Think about this now. My hands, because of the ring, probably not. But if the ring was gone, now all of a sudden, they fold over and it's very symmetrical. So the idea of inverses is across this line we can fold across and the two things match up with each other. The composition, if you plugged one function in, if you plugged a function into its inverse or an inverse into the function, you get this idea of the inverse into the function or the function into the inverse. You always get back to this line y equals x. You get back to this idea of x. So I have 3 ways of telling whether or not something is a function, and that is the first part. I'm going to do this 3 ways. There's one called the inverse test. There's one way to find inverses, and we'll also do this by graphing. So first of all, let's just tell if these are inverses. Well, the inverse test for this, if I take the g of x and I plug it into the f of x, and I take the f of x and plug it into the g of x, and I get x, that tells me there's inverses. So I'm going to do f of g of x. Oh, I've seen that before. Composition. And I'm going to do g of f of x. And I've also seen that before. And they're inverses if they equal x. So I put an x there, but I'm really testing to see, do I get to x when I do the composition? That tells me they're inverses. So I'm going to take the g here, and I'm going to plug it into the f there for that x. It becomes 5 minus 3 times this goes in for that x. 5 minus 2x over 3 all over 2. All right, so my favorite property in math, and I know, I'm even gonna put this on video. I know there was a song, but I was using it a long time before the song, okay? My favorite property, I call it the whap whap property, okay? And I honestly have been doing this since 1996. So I should have copyrighted it. It should be in my name, and they should be paying me money. Everybody's told me it's a horrible song. Okay, this is my property when I'm like whapping things out. Okay, so do you see anything that, boom, eliminates right now? What do you see? What goes away? Nope, not yet. The threes. 3 times 1 over 3. Wow. 5 minus 2x over 2. Okay, now I'm going to distribute the negative through. 5 minus 5, gone. Minus a negative 2x is plus 2x. I'm distributing the negative. I get 2x over 2, and I get x. So far, the inverse test applies because when I plugged one into the other one, it worked. Okay? I'm going to do the same thing for g of f of x. So I'm going to take the f of x and I'm going to plug it into the g. So I take this f of x and I'm going to shove it in right there for the g of x. So I go 5 minus 2 times, this goes in for that x, which is 5 minus 3x over 2, all over 2, or all over 3 on the bottom. And I plug that in for that x. And you can see it's pretty much the same math. The 2's are gone, they whap out. 5 minus 3x all over 3. The 5's will be gone. The minus will go with that minus. I'll get 3x over 3, and I get x. And that's called the inverse test. You can always tell if things are inverses by plugging one into the other one and seeing if you get x. But honestly, I never do it that way. Did you guys do any inverse work last year? Do you remember doing inverses, f to the negative 1 of x or not? Ish. Okay. There's a way to see, another way to see if one is the inverse of the other one, and that's actually find the inverse of one of the functions. So I'm going to take f of x, and I'm going to find the inverse. I'm going to find f to the negative 1 of x. So the rule to find an inverse is you take the x and the y and you switch them around and then you solve. So this right here is y equals 5 minus 3x over 2. Y equals 5 minus, minus 3x over 2. 5 minus 3x over 2. And the rule is if I switch the x and the y, I'll be able to find the inverse. F to the negative 1 of x should be, these x's and the y's, they literally switch spots. X equals 5 minus 3y over 2. And then I solve for the x value, or I solve for the y value rather. So switch the x and the y, switch the x and the y, now I'm going to solve for the y. And I'll multiply both sides by 2. I get 2x equals 5 minus 3y. I'll minus the 5 over. 2x minus 5 equals negative 3y, and I'll divide by negative 3. Now, this is a little bit tricky, but that negative, I can pull it out and then distribute it through, and the essence of that negative is it changes both signs up on top if I pull it off the bottom. Think about it. If I pull it out in front, there's a negative out in front. Now I'm going to distribute it through. It becomes positive 5 minus 2x over 3. Okay, this is the inverse of f. Do you notice anything? It's g. The inverse of f, when I switch the x and the y, is g. This is another inverse test. Simply find the inverse of one and see if it's the other one. You could run through the composition and get x's. You could find the inverse of one or get the other one. And then the last one is graph. And I went ahead and took the liberty before class of putting them on the axes. Here it is. Y equals 5x minus 3 over 2. Y equals 5x minus 2 over 3. Look at the graph. And I'm going to add something right here in this spot right here. I'm going to add the inverse line, y equals x. And I got it right there. And it almost, to me, it almost looks like a dragonfly on this one. But do you see how the line y equals x, if I was to fold it, that whole butterfly thing works? You following me? That's another test if you had a graphing utility. You could actually graph it and graph y equals x, and you should be able to, in your brain, fold it over the line. And a lot of this class is about graphical analysis, so there's the algebra way, and then there's the look at the graph and see if they flip over the line y equals x way. And those two are called inverses. So we'll turn the page, and we're going to go through some inverses right here. And there's my switch x and y. I even say it on this page. To find an inverse, switch x and y, then solve for y. The graphs of inverse functions will be mirror images over the line y equals x. Just a note, we're going to have to mess with the domain and range. So let's do this set of ordered pairs with a blue dot. Go ahead right now. There's 4 ordered pairs. Put them on that graph right now with blue dots. Whoa, Mylanta. -3 up to, so we have that, okay? Now the inverse is literally, okay, it's literally take your x's and your y's and you switch them. Well, I don't have an x and a y here, but I do have ordered pairs. So if this was like the function f of x, well, the inverse of the function would literally be what you would get if you went -4, 1, -2, 3, -6, 0, and 2, -3. And I'm going to use a red dot to do those. And I'm going to look at the picture and see if my little graphic test, if it fits. So I'll go left 4, down 1. Left 4, up 1. Left 2, up 3. And left 6, 1, 2, 3, 4, 5, 6, up 0. And right 2 and down 3. Ooh, I'm also going to put the line y equals x on there. Y equals x right there, like, oh, I missed. Don't do that. Let's try this again. Y equals x goes like that and like that. And I ask myself, hey, does the butterfly thing work? And look at that. It's such a nice little picture right there. The butterfly thing works. All right. I'm going to give you some specific directions now. I want to see if you can do this. Okay? And it's very process oriented. Do this, do this, do this. Okay. Step 1. See if you can do this by hand now. You should be able to graph y equals 3x minus 6. Do it by hand. I'm going to do that one in blue. And I want to see it. So down 6, up 3 over 1. Should be able to hopefully graph that one. Just graph y equals 3x minus 6. That is correct. That is correct. We can graph a line. Good. Graph a line. Close. Hey, you can graph a line. Good. All right, so I put a little dot down 6. Y-intercept is negative 1, 2, 3, 4, 5, 6. And then it's up 3 over 1, up 3 over 1, up 3 over 1. And I'm going to try to draw a pretty good straight line here. I want a good picture of the graph. There it is. Okay, now we're going to find step 2. What you're going to do is you're going to find the inverse of the function. So we're going to find f to the -1 of x. I usually put a little colon. I'm doing the work to show the inverse by taking the x and the y and switching them. and then put it in the y equals mx plus b form. Should be able to do that. Take the x and the y, switch their spots. So instead of y equals 3x minus 6, x equals 3y minus 6, and then solve it out for the y. See what you get. And you put that into y equals mx plus b. Yeah, you got to solve it now. You reordered the letters. You're still going to get the y by itself now. Yep, it's 1/3. Yep. X over 3 is 1/3. So I take my x and the y and I switch them. I got x equals 3y minus 6. I got to get that y by itself so I can grab it. So I'll add the 6, and then I'll divide by the 3. And the 3 goes with both. The way I would write that, there's a 1 in front of the x. The way I would write that is y equals 1/3 of x, and then 3 and a 6 is 2. Okay, next step, graph y equals 1/3 x plus 2. Put it on your picture. Good, gotten it, get it. Does this look familiar from last year or no? Be honest. About half of you say no and about half of you say yes. So it probably wasn't a huge item, but maybe you touched on it at one point, sounds like. All right, so plus 2, I got a dot. It's up 3, or up 1 and over 3, 1, 2, 3, or down 1 and over 3, down 1 and over 1, 2, 3. So this graph looks something like this. And then I'm also going to, on all of these, put my inverse line, y equals x. Y equals x goes like this. And something's happening here that should always happen if you have inverses. If the inverse crosses the line, they should cross together. Like the fact that this one and this one both cross the same y equals x line tells me I probably did it right. So I got the butterfly test. I know the inverse of the blue part is the red part. It all worked out, and we'll go from there. All right. That really was probably Algebra 2 stuff. Let's extend the idea. Graph by hand y equals x squared plus 2. You should know what the shape is. Good. A U shape, what's the plus 2 do? Yeah, I should have a U shape up 2. So I'm going to do that in blue. And I'm going to be pretty specific when I do this. I'm going to go through 0, 0. I'm going to go through that over 1, up 1, and then maybe even 2 by 1, 2, 3, 4. And I'm going to go like that, something like that. That's a pretty good graph. Okay? So what I'm going to do with this now is I'm going to find the inverse. Now, I'm actually going to do this one with you because it's quirky. All right, so f to the negative 1 of x tells me to take the x and the y and switch them. X equals y squared plus 2. Okay, and now I'm going to move the 2 over. Minus 2 minus 2. I get y squared equals x minus 2. And then I'm going to square root to get rid of the squared. Anybody know what to do in here? There's something going on here when I square root that variable. You guys remember the idea of entering when I square root a variable like that? I introduce the idea of plus or minus on the other side. So plus or minus x minus 2. And the fact that 1y gives me out a plus x and a minus x tells me something about this graph that's going to get backed up when I actually graph it. This one is not a function. Therefore, theoretically, what we should say is there is no inverse. Inverse of f of x. Now I'm going to go ahead and draw what we have up here, because when I draw the graph, you'll be like, oh, that makes sense. Something's going on here. So I'm going to graph the plus 1. I'm going to graph the two pieces of this, y equals root x minus 2 and y equals negative root x minus 2. Okay, what's root? Shape. Hill. Minus 2 underneath does what? 2 to the right. Hill, 2 to the right. Hill, 2 to the right. So here's part of it. Okay, the second one, still hill 2 to the right. What's a minus in front of a function do? Flips it. So I have a hill that flipped 2 to the right. Can anybody tell me why, looking at the picture, I could say that it also doesn't have an inverse because of something going on? Yes, anybody? Yeah. Oh my goodness, it fails the vertical line test. Fails vertical line test. So I did it correctly, and you can see that, oh, here's the line y equals f of x. Here's the line y equals f of that. I mean, the 2/2 are good, but if we were worried about functions, if we were worried about is the inverse an actual function, we would have to say right here, it does not pass the vertical line test. It does not have an inverse. All right, let's do this one. Let's see if we can do that. So graph y equals x cubed minus 1 for me, please. Graph that guy. Should know what it looks like, I hope. I hope you can just throw that up in about 3 seconds. My favorite graph, minus 1. Yes, you guys are rocking it. Johnny T, moved it the wrong direction. Johnny T, that minus 1 is outside the parentheses. It should have dropped. X cubed minus 1 drops right down to here, minus 1. And now it's Johnny T looking guy like that. So that's that one. Okay, let's find the inverse by switching the x and the y around. So I'm going to take those two values and let's find the inverse of the function by taking the x and the y and switching them. And let's see what your algebra skills are from last year. I got to get the y by itself. What's first? Add the 1. I got x plus 1 equals y cubed. And now I got to get rid of a cubed.
Cube root.
Yep, there's a cube root button. Oh, I know what that shape is anyway. There's a cube root button. And I get y equals. Now, with odd root, odds can be positive or negative. You actually don't enter the idea of the plus or minus here. You just leave it. Cube root. All right, cube root of x plus 1. All right, cube root shape from 2 days ago. Sideways Johnny T. Plus 1 under the radical. Left 1. Johnny T sideways, left 1. So Johnny T sideways, left 1 is going to look like this. And like this. And I missed a little bit, but I'm gonna draw the line y equals x in there. Something like that. Do you think the picture fits? Does it still have a function, even though the one x squared we said doesn't have an inverse? Is the red one a function? Yeah, it passes the vertical line test. I got the line y equals x in there. And that one's kind of a pretty one. It's got the butterfly effect that I can put the 2/2 together and go from there. All right, this is a test question. I think I changed the 3. The 3 is not a 3, it's like a 4 or 2, depending on what form you have. And we will do a review for all of this stuff. We have the review Monday. It's a really, really good review. If you do the review, you'll do well in the test. And then we take a test on Tuesday and Wednesday, so we'll do that. All right, so it wants us to graph. It wants us to find and graph the inverse. Find the inverse and graph all 3 things. It wants us to graph the function, the inverse, and y equals x. It wants us to graph them all. So step 1, go ahead in blue and graph that right there. Let's see what we get. Good, good. So a hill graph, it's under the radical. So So that under the plus 3 under the radical should shift it over to the left 3. So I'm going to draw up a hill that went left 3 right about here. It goes 1, 1, and actually goes through over 4 up 2. How exact you are with those, I don't really care that much. Hopefully you can, as you progress through here, we can get more and more exact. So that's f of x. All right, now I'm going to change colors, and I'm going to go to the inverse of f of x. So I want to find the inverse, f to the negative 1 of x. And that tells me to take the x and the y is right here. It's not in there, but I'm going to take those two and I'm going to switch them. So it becomes x equals root y plus 3. And we got to go get the y by itself again. So I'm going to do the math here. Well, I got to square root. I got to get rid of a square root. So I'm going to square it. I'm going to square it, and I get x squared equals y plus 3. I'm not square rooting, so I don't add in any plus or minuses in there. It just, I square them, and I got to there. And now I'll minus the 3. I'll minus the 3. And I get x squared minus 3 equals y, or y equals x squared minus 3. Get it down to there. So what I do with that one, I'm going to take it. I know it's a U-shaped graph because it's x squared and it's down 3. So I get 1, 2, 3, and I get this. And I get that. Does the butterfly thing work? It doesn't, does it? Huh. What to do, what to do. You know what? Oh my goodness. Maybe if I was able to say something about this, if you can see it now, maybe if I was able to say something about this in terms of a domain restriction, maybe I could still make it work out. Max, what do you think? Make the inverse of piecewise function. Oh my gosh, you're on the right track. How about we just get rid of part of the inverse? Swan, what do you think? Yeah, what would happen if I got rid of that branch? I'm going to see if I can do this. I'm going to undo it. Oh, there it is. Oh, it was. I'm going to redo it. Okay, so there's that. Okay, so the red dotty part right here, if I went like this, oh my gosh, now when I put in y equals x right here, now that inverse thing, now it works. The butterfly effect works. So if I could only pick this half of the graph, I could still say that. So I'm gonna qualify this. So the inverse of f of x is equal to y equals x squared minus 3 when I start at my x value of 0 and I go to the right. When x is greater than or equal to 0, and I have it. So I can still have an inverse on this one if I like domain restrict that guy right there, and that's kind of a weird one. There's one like that on the test. All right, last thing that goes with this, and this is a little sidebar note, and this was in the book and part of the stuff, but it's really not that mind-blowing, but let's look at this. There is an actual thing called the horizontal line test. You have one called the vertical line test. There's actually one called the horizontal line test. It works like this. Some functions do not have inverses. If you can draw a horizontal line across the graph and intersect 2 points, then the function doesn't have an inverse. It's called a horizontal line test. In other words, if I can do this and hit twice, there is no inverse. The reason for that is this. If I took this thing and I flipped it over the line y equals x, if I flip it, this one actually goes like this. And I'm going to erase that. And it would fail the vertical line test. So when you flip ones that hit twice, the flipped version will fail the vertical line test. So the horizontal line test kind of tells you if the vertical line test will work for the inverses. Boy, that sounded like Greek. The horizontal line test tells you if the vertical line test will work for the inverses. I don't know if that made sense to you or not, but does this one have an inverse? Nope. no inverse, no inverse. How about this one? That one looks okay. This one would have a yes, it would have an inverse exists. Inverse exists. Also within this, a function only has an inverse if it's 1 to 1. If you go frontwards, this is called a 1 to 1 function because each one of these elements is paired exactly with 1. Oh, I have it down here, 1 to 1. This one is not a 1 to 1 function. When I switch the x and the y around and I try to go backwards, this way it's a function, but coming back, one input gives you 2 outputs. So when I switch the x and the y around, it doesn't have an inverse. I don't actually use this page a lot. It was part of the material, and we'll go from there. All right, that's it. That's inverse lesson. Should be able to do your homework and go from there.